Hello, my name is Jordan Kester, and today I did my mammal brain dissection. I'm just gonna go through and kind of show you some of the parts of the brain that I learned about while dissecting this little sheep brain. So, first off, observing the brain from the outside, you can see that it's got a thin membrane surrounding all its surfaces. I believe the dura mater is missing here, would have been removed when the brain was removed, but still remaining we have the pia mater that would lie close to the brain, and then the arachnoid matter that would be attached to the pia mater on top of that. And I kind of peeled some of it away. Over on this side over here, you can nicely see kind of the membrane layer there of the pia and the arachnoid attached together. And if you'd peel it away, you would have exposed brain matter underneath there. So that would be the three layers: the dura that's gone, the arachnoid in the middle, and the pia lying close to the brain. Still looking at the outside, you can observe on the surface of the cerebral cortex, the gyri and the sulci, making the folds in the surface of the cerebrum, and that's creating more surface area for the nerves, greater surface area for the neurons to allow there to be more of them. If we flip this brain over to from the dorsal side over to the ventral side here, we're gonna observe a few things on the bottom. A lot of them are missing, but some of the cranial nerves are still in place. The other ones would have been all over across here, all 12 of them in total. But we can still kind of see the olfactory tracts and what would have been the olfactory bulbs up front here. But there's what's left of the olfactory tracts. And in the middle here, we have this optic chiasma, the optic chiasma, this X shape here, part of it's gone. But that is where the optic nerve would come in on each side and cross over together a little bit before it goes into the brain. And that crossing kind of helps us see the way we do, with the nerves from each side crossing over a little bit one to the other. Still looking at the outside of the brain here. This gives us a really good view of where the spinal cord would be running down to the rest of the spinal column in the vertebral column there. And coming up from that, we have our medulla oblongata sitting right here. Then we have our pons sitting on top of the medulla, and the midbrain sitting up on top of the pons there. And the midbrain, pons, and medulla all together make up the brain stem. Now, I cut down the brain long ways, creating two hemispheres. Gives you a really nice cross-section view of the mammal brain. So, once again, spinal cord, medulla, pons, and midbrain. In the back, we have a real nice view of the cerebellum. That's kind of the cerebellum helps us hold posture and is where our balance comes from. Then on top of all that, we have the parts of the diencephalon, which include the thalamus, which is located in here, and the hypothalamus, which is below the thalamus, kind of across here. Part of the hypothalamus would have been the hypophysis, which I believe is no longer connected, but would have kind of dangled below here, and would have been part with the pituitary gland, I believe. And then the epithalamus is up kind of above the thalamus in this area and includes the pineal gland or the pineal body, which would be up here. All that is part of the diencephalon. On to the largest part of the brain, the cerebrum, lying up top, and the majority of what you can see looking at the outside of the brain. The cerebrum, I have it. It's naturally divided into two hemispheres, and we have 4 lobes on each hemisphere. We have our frontal lobe, our parietal lobe, temporal lobe, and occipital lobe. If we take a look over at this right hemisphere over here, I made another cut that allows us to see very nicely the 2 different matters that make up the brain. We have the outer gray matter that you can see from the outside, and then you see these nice veins of white matter on the inside. The white matter is the myelinated axons of the neurons, and gray matter is made up more of unmyelinated axons and cell bodies. The rest of it I found a little easier to find on this left hemisphere. Right here, the corpus callosum is kind of a thick band of material there connecting both hemispheres, and that's a major connection of information between the 2 sides as well. A lot of the neural pathways go from the right and left side through that part. There is 4 ventricles in the brain. Ventricle 1 and 2 are the lateral ventricles sitting on the right and left half sides, and you can really see it nicely on this left side. The lateral ventricle allows me to kind of put this probe way inside there. You can feel it goes pretty deep. Pretty good sized ventricle runs across there. Kind of gets covered up by this thin membrane here. The septum pellucidum lies between the 1 and 2 ventricles. The third ventricle lies back here behind posterior to the thalamus. You have the third ventricle with the cerebral aqueduct running along here down to the fourth ventricle that sits kind of below the cerebellum, right down here. And that fourth ventricle is going to be connecting to the central canal, which will run along the inside of the, eventually going down to the spinal cord and running all the way down the spinal column. The central canal does. And that mostly sums up the parts we've learned about on the mammal brain.